Hello, welcome to the HVAC 2.0 show. I'm Nate Adams, and we have a light night with the guild tonight. Tanner and Rudy both have a birthday, which is cool. Abby is traveling, and Ken is off watching drummers. It's actually one of his favorite drummers was in town, so he took off to go see them. So we got myself, Jeff Howard in Indianapolis, and Ted Kidd up in Rochester tonight. So, and this actually ends up working out pretty well because I wanted to chat about various challenges with heat pumps so that you can figure out how to win with them, to have them actually do things well. Because all three of us here are staunch supporters of heat pumps, even if perhaps politically you might not expect us to be. But it's primarily a physics thing. They make houses more comfortable if you use them correctly. So like Jeff, have you gotten the feedback that I have, which is I can't believe it's the same house?
Yeah, absolutely. Even from people that are just like, I threw in a heat pump and didn't know it would be this comfortable.
Yeah.
Always heard that heat pump sucked. My mother had one and always complained. I mean, all these wives' tales things where they blame the equipment for bad design or bad install.
Or bad setup. And you
Or
want to
bad
get all
shell.
three close. Yep, bad shell. Yeah, it's hey, something's going wrong, kick the dog.
Always easier to blame
Exactly.
everybody
Kicking
else
the dog.
instead of yourself.
Blame everybody else.
Yeah, man, it's
the
kind of wild.
equipment's fault.
Yeah.
You blame whoever can't defend himself.
Yeah, Jay already hopped in, or bad house, so it's yeah. There's all these different things that can affect performance and comfort. But one thing I thought was really interesting is one of our houses, the Wizard House, which is this little tiny 672 square foot ranch that has bad shell. I actually haven't blower door tested it, which is ironic. I installed a heat pump without blower door testing, but I also knew that it was a 1.5 ton. And there was no way that I wouldn't be able to get the shell to make that work if I needed to, and I know how to do all the work. But fix the basement of it because it was a train wreck. I joked it was a river runs through it without Brad Pitt. But the walls are empty, and the attic has like 2 inches of insulation in it. And my wife said that's the most comfortable home she's ever been in. So even with the bad shell, the heat pump did a pretty good job. And we'll talk about why in a little bit. But anyway, on with the show, winning with heat pumps. And by the way, the going both ways, this cracked me up. So my friend Justin Gillis, co-author of this book, put in here, heat pumps are bisexual air conditioners. They go both ways. It's a funny way to look at it. He laughed, and I couldn't hardly believe that he put that in the book, but there it is in print. It's a good way to think of them. Air conditioners are one way. Heat pumps are two-way. So a couple of challenges wanted to talk about tonight. So these are very practical, and I'm going to do my best to hold language so that it's still somewhat homeowner and policymaker friendly, because I think a few people will watch this because of this, because I'm also going to end with taking a really, really quick look at a bill that is looking to be introduced soon that would incentivize distributors to change all of their air conditioners over to heat pumps. Which is mainly going to be single stage stuff, because that's 85% of stock, something like that. But anyway, heat pump challenges, 4 to talk about. High external static pressure, also known, we call it duct pressure, and that's actually thanks to Jeff. Because if as a consumer you hear external static pressure or total external static pressure, what does that mean? It's like telling a joke and then having to explain the whole thing. It's just dumb. It's not useful, but it's the pressure inside your ducts. Oh, okay. So that's why we call it that. We'll talk some about sizing correctly, a bunch of different ways to come at it. And then how do we provide better comfort? Because done right, as all of us here know well, heat pumps can provide amazing comfort in homes, but you have to know how to use them. And then changeover temperatures. So that's thinking mainly about hybrids, which hybrids are the easy path to at least partial electrification, where you stack a heat pump on top of a furnace instead of a furnace and an air conditioner. All right. High static. So big thanks in this to Jim Bergman of MeasureQuick and his daughter Val. Val sent me a nice um, a data set of 800 homes across the country and the static pressure that was tested there. And it wasn't pretty. And I'll show you in a minute. And another key thing to keep in mind is these are companies that are testing, and a lot of these are post install of a new piece of equipment, which means reality is probably worse than what this data is. I can't prove
Yeah,
that. I
yeah.
don't know.
Companies that are testing are generally better companies than the average company out there.
Yep.
So these are people that are measuring, that know how to measure. I mean, the last company Jeff worked for, they didn't even know. Not a single person in the company knew how to do static pressure. Not even the training guy.
That's okay because they only do
It's a big company.
50 million a year. That's a lot of equipment being installed, missing what is arguably the key metric. I mean, Jeff and I have gone back and forth on this. Like, if I can only know one metric about an existing install, what do I want to know? And static is pretty much our favorite. Do you have another one, Jeff?
No, I mean, as a starting and knowing where you're going, it's I think a very, very important key. I know a lot of people are like, yeah, they're not worried about it. They're worried about the airflow delivery, but I mean, what are you
They're
doing to the
related.
system? Yeah,
Yeah.
exactly.
They're strongly related. And then, I mean, you really kind of blew my mind in measuring consistently and finding going from a PSC motor to an EC motor, which is the new mandated kind, that's what's on the screen here, how that bumps pressure on average about 30%.
Yeah, and I think
So,
Jim Bergman's data set proved the same thing.
yeah,
I think
well,
it's
it
in one of
makes
his
sense.
articles on MeasureQuick. So
Yeah, I mean, PSCs just spin like like a cartoon character when they're going to take off running. Their legs go, and all of a sudden, pew, they take off. Only it never goes. Pew. It just doesn't move the airflow. So in 99, or sorry, not 99, 2019. Uh, there we are, J Trammell. It's very common to see above zero 0.8 on systems with ECM blowers, and also over 1 inch. Um, and then for him, if he isn't under an inch on a system, if it's below an inch on a system he didn't install, he's impressed. Yeah, and the bad part is around an inch, the odds of early failure are pretty high. What would you say, Jeff? 50-50 that it's going to eat itself?
I think a lot of things that changed they can run them up to an inch and a half before we really start to see that 50-50 or greater failure. So
Okay.
but still 1 in 3 within the life
But
of
is
that
it
10-year part warranty from the manufacturer. So
you're still likely to see, like on a furnace, you're still likely to see hitting high limit, right? And early failure on heat exchangers.
yeah, the worst during PSC when you have high static on a PSC motor because you drive down the CFM, which will of
Right.
course leave the heat in the unit and it overheats. Usually we'll see that, but that's usually a telltale sign too when someone's replacing their equipment and they're saying that's happening.
Yeah, the heat exchanger's cracking because it got too hot from not enough airflow. Then expand, contract as it short cycles because it's too big. Yeah, they eat themselves. And yeah, Jay said probably higher failure rate over 5 to 10 years. So it's the jury's out, but I mean these motors are between $1,000 and $2,000 a piece to replace generally. So that's painful if
So
you're doing it.
one thing that I'm seeing as well is that more and more companies are doing a 10 and 1. So hey, we'll register it, whatever for you for the original owner, but we're only going to give you a 1-year labor warranty. So, I mean, I
There
guess
you
if
go.
you want to have a cash cow that you got to go replace motors to, then don't check static. You may not have any fans or, raving reviews, but that's all right. You made your
Nothing like
money.
burning Goodwill.
Well, and the manufacturers are going to start clamping down on that, aren't they?
Well, I mean, I would, from what I've gotten, I don't know about you, Nate, but talking to them, they've got so many other things going on that they know about it,
55.
but they don't do anything about it.
Yeah.
Okay.
It wouldn't
So they're
surprise me
aware.
if in a couple of years, I mean, particularly once we get over the refrigerant transition. So the new refrigerants are required, was it January 1st of 25, if memory serves. So A2Ls are coming. So R32 and R454B are the two that it's mostly going to move to. But yeah, it's just wild. And there's Jay putting in good um, systems. He does 10 and 10 with manufacturer backed labor. So 10-year parts and 10-year labor.
So they are keeping track of the address because he's saying that, they'll flag a system if it has multiple major failures.
Yeah, which they'll probably be seeing more.
We're going back to this address again? I think we'll send a rep.
Yeah, exactly. But so the DOE, when they mandated the EC motors, I always want to say ECM, but it's electronically commutating motor. So ECM motor is motor. So I get a hard time for that. That's, and rightfully so. But look at the numbers that DOE was assuming for installs. So units with an internal evaporator coil, so it's like a heat pump system, 1/2 inch of water column, which most manufacturers, that's their normal limit. Would you agree with that, Jeff? Like most of them say 1/2 inch or below. They may give you specs above that, but they're asking for a 1/2 inch or below.
Yeah, on all service stickers or service tags on every gas furnace manufacturer, it shows max heating TESP is 0.5.
Yeah.
Again, they may show you the data charts and the engineering or blower performance charts that go up to 0.8, 0.9, 1, but you won't see anything above 1.
Yeah, I haven't seen anything over 1 either. And it usually hurts airflow when you get that high. So internal evaporator coil, this is like a heat pump. It's an air handler system, so it doesn't have a furnace. It's just the coil and the fan, 1/2 inch. Unit's designed to be paired with an evaporator coil, so that's your furnace and air conditioner combo. 0.65 is what they were assuming. And in mobile home systems, which I don't know what they're smoking here, but 0.3.
That seems upside down. I thought those were all high pressure systems.
I thought they were like 0.8. Yeah, you have to use special
so
air handlers usually.
That's a mistype.
Yeah.
No, I think that's still what they shoot for, but I've never seen one. I've seen it on different reports on new mobile home builds, whatever.
Yeah.
Of 0.3.
Yeah.
And that's what they design it for, but it's never that.
Yeah.
Okay.
Well, it's nothing like putting a 4-ton system on 2.5 tons of ductwork. Because our house is actually a manufactured home. And if you give that thing 3 tons of airflow, it sounds like the house is going to come apart. It's noisy. So Ryan Kerr, he works for Plum Supply in Iowa. So he works for a distributor. That I think the gateway for OEMs and policing it, meaning static pressure, will be boards that read external static pressure. So yeah, wouldn't surprise me.
Yeah, the Infinity will report that back, won't it, Jeff?
The Infinity reports it back, and it can actually hit it back to the contractor as well. And when it's connected to the Carrier Bryant servers, it's getting back to them as well. So there's a more direct path back, but on the board there are some units that read it, right? Yep. But a lot of controls on communicating systems also read it. So I think that's going to be a bigger game changer with more communicating systems going in inverters.
Yeah. Here's Rick Benbenek down in Louisiana. Carrier FJ4 air handler tested at 1.0. This is on the new nameplates, so they're starting to get there. And what was it, Jeff? They kick an error over 1.1, I think.
That's not communicating, so that's no one's ever going to know unless they actually check on that FJ.
Yep.
We've never gotten an exact number. 1.18 is kind of been the range that I've figured from all the ones that I've seen on the old white flip down controls, and then also the new Wi-Fi controls. Got it.
So these were the numbers that DOE was planning systems would be running at. So their assumptions are 0.3 to 0.65. And in general, 0.7 is that's where the risk of early failure becomes elevated. It seems like the manufacturers are trying to engineer against that to some degree now, but still that's the generally agreed upon place where things start getting potentially ugly. And 1/2 inch is what generally they're shooting for. So the data set that Jim and Val gave me showed that fully 70% of systems were over that 1/2 inch. And this is actual tested systems. It's pretty nationally representative. And this is, like we said,
Again,
probably better than reality.
Good, measured by better than average companies, because these are companies that know how to measure.
Exactly.
And are measuring.
Yep. So this is a challenge. And like one big thing that happens with heat pumps is because their outputs are lower, they need to run longer. So where a furnace might handle straining the edge, you need to be careful with heat pumps. And we'll get to that with sizing in a little bit. Now, 47% of this data set were over 7/10 of an inch. So Michael Hausch made this little meme of Pac-Man eating motors, high static, nom nom nom. Yeah, it'll eat it, and it's not hard to get over an inch. So, because the other thing that is really tricky that Jeff found is when you go from a PSC to an EC motor, you go up by 30%. So if you're at 0.7 now with a PSC motor, it's the old school kind of motor, and you move to an EC motor, you might push an inch. And that's where you might get some risk. So you want to be aware of this. And also the low airflow, like Jeff was saying earlier, if the airflow isn't high enough over a furnace heat exchanger, they get too warm, they overexpand, and then when they shut off, they contract. And if you're giving them too much temperature difference and too many cycles, they crack. And you really want to replace
metal fatigue sets in. It's like
what's
overbending a paper. Metal fatigue sets in. It's like overbending a paper clip.
Yeah, or coat hanger or whatever you want. That's how you break metal. You break the crystalline structure until it just shatters. Now, how do you reduce this risk? So with the HVAC 2.0 free quote process, we offer static pressure testing and then have people sign off on taking it or not. And so this is just a test one, but clicked accepted. And you can do this any which way you want. Doesn't matter, but it's good if you have a system to do this directly.
Yeah, build a process on your own if you like. We've got one already built that you can use.
Yep, exactly. And it's inexpensive. The inexpensive accounts are $6 a month, and then it's $10 for each one of these reports. So it's not a ton of money.
Yeah, you don't even have to buy the report.
Nope,
so you
would
buy the report.
The $6 will get you that. $6 get you this. So then you can at least document. And then on the report, it shows what the static is, or the duct pressure, excuse me. I have to speak both languages. It's like Celsius and Fahrenheit. But you can either accept it or they can decline, in which case it pops a message that testing declined, client assumes risk. So if you have an argument later, you have this to point back to.
Yeah, you don't want to just ask the question. You want to document the answer.
Yep.
So that because a lot of times 80% of homeowners that you're going to have problems with, it's because they forgot. And so you present this to them and they're like, oh, that's right. I did assume that risk. I remember.
Yeah.
It might even be 95%. There are very few really bad people out there. And even the ones that are, you put this stuff in front of them, busted.
Yeah, exactly. Will it hold up in court? Who knows? But
Who knows?
It will significantly reduce the risk of going to court in the first place. I mean, the story like it keeps coming up of Tim. My jaw is still just dropped from Tim Nahr selling a system last year, warning them that there were likely going to be some issues. Static wasn't totally one of them, but because he had run them through the whole process, they weren't happy with the comfort. They needed to go down a size, and they ended up paying him to put a new system in again. So that sort of thing can happen if you set the cards up right. Where if you don't, you're going to be there pretending to fix stuff.
Changing the gas pressure, lower than it should be, not doing that correctly. Yeah, we've seen that far too often. Trying to increase the blower speed, not paying attention to the duct pressure.
Yeah, so many risks. I mean, there's not that much you can adjust on the single stage stuff. It's hard. The variable speed is nice. I mean, I had one system that came in higher than I wanted, and I just turned the airflow down. I turned it from efficiency settings to comfort settings, and it got quieter, and it worked fine. So you can do that, but you need to know what you're doing. Um, and one way that you can also reduce static pressure is, this is badass HVAC. I'm not going to go over this whole thing, but the key thing is to look at the BAD, which stands for big air drop or big ash drop, for the PG version. And this is what it looks like. It's the return plenum that comes down. So this is a basement system. The air is coming down here through the filter, down and around and up through the system. This is just a really big box for the return. Making this bigger and then making the supply side bigger can help a great deal on duct pressure. Is it all of it? No, you probably need to downsize too if you're running high pressures. But if you do this and you downsize a size or two, I mean, I've only had a handful of systems come out above 1/2 inch. Generally, they come in 0.3, 0.4. The one that we did at the game house came in at 0.13. So it can be done. Jeff, what numbers you usually see on your installs?
0.28, somewhere right around 0.3.
Yeah. 0.3 is kind of
0.34. Yeah.
Yeah. Yeah, I've seen plenty of those on low, like 0.04, which freaked me out the first couple of times I saw it, and now it doesn't bother me. The air's getting there. As long as the ducts aren't too leaky, the air will go where it's supposed to go. But this helps a lot with static and duct pressure. And you can offer this. This is part of the free quote offering. So this is the equipment side. But on the install, this is where better filtration matters. So running a bigger drop and a bigger filter help here immensely.
Edgar's question: what size media cabinet is it? As big as you can get.
Yeah, that's a great question. Is the 1510? That's the 28 by 31.
Which one?
The April Air. That's like the Geo one.
Yeah.
But yeah, the bigger you can get, and when you get to 4 tons, you either want to have that biggest one or put 2 in, like 2 20 by 20 25s, which can be interesting, but you can do it with a side bottom or something like that. Sizing correctly. So this is always a challenge with heat pumps, because with the furnace, particularly older ones that ran high output temperatures, they're fine. And we consistently find that homes oftentimes only need 2 or 3 tons of heating, which will mess with you. I'm from Cleveland. That's not a warm climate. And I'd say about half of houses in Cleveland, you could pull out a furnace, put in a heat pump, and it'll work. Need a little backup heat, but no big deal. Jeff, I'm surprised in your market, Indianapolis, which is the same climate as Cleveland, and actually Ted is also climate zone 5 as well. All of our design temps are pretty similar. But there's a lot of heat pumps in your market for the new builds.
Yeah, I mean, it's either if the house is total electric or the neighborhood's total electric.
Yeah,
they would be heat pumps. Yep.
There's not that many of those in Cleveland. There was one builder in particular that did that, a guy named Schmidt. But that's basically it. So, okay, sizing correctly. A couple different things to think about. So test your duct pressure. Duct pressure is ultimately going to limit what size equipment you can put in. So you got to figure out how you're going to get around that. That may lead to putting in a hybrid. Because you may not have enough ductwork to put a heat pump in that can cover heat load. And that leads us to sizing the cooling, which is also critical for dehumidification, which we've done, I don't know, 6 episodes on at this point. We talk about dehumidification a lot. But if you size the cooling with manual J, you may be surprised just how much of heat load that covers. I think my buddy Mike Platko has a 13 or 1400 square foot, 1.5 story that's leaky as a sieve. He has a 2-ton variable speed heat pump on top of a 60K furnace. That 2-ton heat pump does his house down to 15 degrees. He wouldn't have guessed that. I wouldn't have guessed that. But try it out. Put something in, track it, see what happens. Particularly on your own home. That's a wonderful place to experiment. And then you can size the blower door or energy use, which that is our preferred method. So duct pressure, we talked about that. Cooling load is usually about half of heating. So this is a Right Soft report from Tim Nahr for one of his clients, and this was him experimenting with air leakage, which actually showed that in this case the load was way too low for what reality was. But the key thing that I want to point out here is that heating is right about double cooling. And it's not
Well,
always
the other
that.
thing to point out here is sometimes you make the assumption that these load calcs are going to come back too high. And in this case, it shows that the load calcs come back too low without infiltration measured. And and I think Jeff ran into that a couple of times on some warranty. You were running a lot of the warranty calls on poorly designed sales at one of your prior employers.
Yes.
And sometimes they would change them. They would downsize and then get bit, right?
Yeah.
Yep.
I mean, you plug in loose and you get a 78,000 load here when the load that came back with actual leakage was 131. Here you can also see when you get leaky.
5785 doesn't really seem all that loose for a house that size. It's only double the square footage, so well, it's almost
2.5 to 1, but I mean, I've seen plenty of 4 to 1s.
Right.
And 3 to 1 is normal. Like before 1950, 3 to 1 is what I walk in expecting. And then we find out what actually happens. But that's where I calibrate from, is 3 to 1. So this house was not out of range. But notice 131 to 45,000. That is a bigger spread. So that's like 2.5 to 1, which this is what you're going to see in leaky houses when stack effect takes over. So this is where it gets dangerous if you don't know some stuff. Going straight electric in a cold climate, man, I wouldn't want to do straight electric without a blower door test. Would you?
Not at all.
Not in a cold climate. I mean, you can get away with it in warmer ones, but in cold, I want blower door test at least, and hopefully energy use too. But the key thing again is to note that a 2 to 1 ratio is fairly common. So if you're sizing to cooling, that's going to be about half what heating is, and you'll oftentimes find out that will end up covering almost all of heat load, unless it's leaky
so
like this.
If the house is below 2,000 square feet, like 17 or 18, 1,600 square feet, which you run into a lot, you might be willing to wait on the blower door, because are you going to get the equipment size wrong?
Well, you can always do a hybrid. I mean, a hybrid's a safe path.
Well, and you can do
you can be
ton with electric resistance.
Yeah, I mean, you got 15 kW. That's 51,000 BTUs.
If the thing's really, really bad, you're going to need to fix it anyway, because the house isn't going to be comfortable no matter what equipment you put in there.
Exactly. Although it definitely does help. So T. Gronis here commented, it stands to reason a variable speed system would be a benefit, as most of the time it will run at reduced capacity and static pressure goes down. Yep.
Yes.
That's another thing that's nice about these. They don't ramp to full speed all that often. If they're truly variable speed, and some of them aren't. A lot of them say they're variable speed. It's just the outdoor unit. Another way to look at load, we talked about this a couple weeks back, but the likely load range. So if you take a given house in a given climate of a given size, most of the houses are going to fall under a certain bell curve. And so we like to think about what's the tightest that something might conceivably be, what's the loosest that it might conceivably be, and it's conceivably too strong. This is trying to cover like 90 or 95%.
So if you've got outliers, but you can't build a curve with the outliers, or the curve gets really skewed.
Yeah, exactly. But if you have an older home, it's going to lean probably towards the higher side of the range. If you have a newer home, it'll probably lean towards the lower. This is different ways to communicate and talk about it. But man, if you don't have blower door prior energy use, I don't know how you get accurate. I really don't. You're just throwing darts and hoping.
So before we move on there? So you talk about hybrid, right? Go hybrid. Well, just something that I think that we should speak about is the fact of the meter fees.
Yeah.
So what we're seeing more and more, basically on the outside of the country, that's slowly moving inward, migrating inward, is meter fees are going up. So and it's actually getting as close to just a few hours away from me to, like today. Yeah.
Yeah, you did a comfort consult today in Columbus, right?
Yes. Yeah.
And people in Columbus are starting to abandon the gas meter and plan to abandon the gas meter because they know that in 2025 the monthly meter fee is going to be how much?
Yearly is going to be about $700.
Yeah,
just for the meter fee.
So $700.
That's
just to be privileged enough to have the meter on the side of their house.
Yeah. And then they got to pay for the gas on top of that. And what do we know about gas prices?
Well, they're very spiky.
They're no longer decoupled from Europe.
Yep.
So we're not going to have abundant cheap anymore because we're exporting.
Yeah.
Here's electric is going to be the new fuel.
It's going to be the most likely, least expensive over time. As long as the utilities aren't stupid about distribution, but you can't get rid of your electric meter anyway.
It's really hard.
You can, but
how big
it's
a system
hard.
are you going to get? How big a solar system you're going to get, and batteries, and
it gets stupid. I mean, to fully go off grid, you're probably looking at between $100,000 and $200,000 for the solar and batteries to do it. That's pretty intense. Most people aren't going to do that. Jay Trammell said cooling and heating load here is usually pretty close. Heating's usually a little more, but not by much. 5 kW can take care of it. Yeah, so that's in the warmer climates, you're going to get closer than that 2 to 1. But it does depend because where Jay is, I'm betting his design temperature is like 20 or 25. So let's take 25 degrees and you're aiming for 70. Was that 45 degrees between them? I think. 45 degrees, where cooling design temperatures, say it's 95 to make it easy. It's probably 93. And you're usually aiming for 75 degree indoor. So that's a 20 degree delta. So a 20 degree delta versus a 45 degree delta. That's why you oftentimes see that close to 2 to 1. It depends. And particularly Jay's paying attention. So you probably run your load calcs different anyway, where somebody who doesn't know what they're doing is just going to put the numbers in stock and get that 2 to 1.
So the other thing reason we lean towards heat pumps is a lot of the really good ones, well, the Carrier anyway, have reheat dehumidification, which means in the shoulder seasons when there's not a lot of sensible load, you can do really, I mean, this equipment is amazing at keeping relative humidity at 50%.
Yeah.
It makes for very happy people in the shoulder seasons and in the summertime when humidity gets out of control. And it makes for really good air quality and durability of houses. So So Austin's not here, but he's been running into some mold problems in Indy from oversized equipment.
It's not the end of that. This is just the beginning of that tsunami, because that takes a couple of years to come through, and that is the curse of efficiency standards. We are beyond what makes sense in general. We're into danger zones, knowing what all of us know. If you run them right, they work fine, but so few people run them right, it makes things interesting. All right, so
Well, you
providing
got to
comfort
lean towards small so that they'll run long.
as
So,
small as you can
and you
get.
got to retrain the homeowners not to turn it off.
Exactly. So that's always interesting. So a couple of things on providing comfort. Variable speed is best. So T already talked about that. Yeah. Variable speed is best. A lot of people aren't going to buy it. Although if you do a good job educating, I mean, that's what we can see consistently with an HVAC 2.0 is there's a flip from 15% variable speed to 15% single. I mean, Jeff, last year, what was it, like the 3 that you sold or something that were single stage? It was like rentals, something along those lines. Wasn't many.
Yeah, 2 or 3.
Yeah. So not a large number. So variable speed is best if you can, but it does cost more. Surface temperatures rule. This is something that if you aren't aware of, you want to be aware of. We'll talk about that. Higher temperatures with lower airflow is one thing to consider, and then we'll have a little round robin as well. But let's talk about mean radiant temperature. This is the average of the surface temperatures around you. And this comes from my book, The Home Comfort Book. This is the first chapter. You can get it for free at natethehouseWhisperer.com. But this is talking about the rules of comfort and how a house works. So this is heat transfer, and it's pretty easy to think about 3 different ways that heat transfers. And I'm using a coffee mug here. So conduction is solid to solid. So that's putting your hand on the cup. The cup is conducting the heat in the coffee into your hand. Convection is if you put your hand over it. So that is through a fluid, which is air or liquid. And then radiation is when you aren't touching, but the heat waves are coming off. So fire is radiant, the sun is radiant. Radiant is really important. It's what we like best as humans. We have a whole bunch of temperature sensors in our bodies, something like 150,000, heavily concentrated in what gets exposed. So face, hands, feet. So 60% of human comfort is based on radiant energy. So let's pull that back to how does that work with HVAC? So this is again out of the same chapter of the book. This is bad mean radiant temperature. So this is a house that doesn't have much insulation. It's not well air sealed. Modeled this as being brick because the brick will absorb a bunch of heat over time, and then it radiates that into the house for hours after the sun goes down. So the system here is oversized, so it's off, and it also doesn't do a very good job of dehumidification. So this is super common when we get to houses. The system's shutting off, the shell sucks, and the humidity is out of control. So these surfaces are all very warm. This is an unhappy guy. He's sweating as he's paying bills. Where if the place is reasonably well insulated, but again, like I said, the Wizard House is not, and my wife really loves the place. So as much as we thought shell was critical, sometimes it's worth trying the HVAC first.
Well, there's not a lot of direct sun on that place, though, right?
No, it's not. It doesn't get baked too bad. But I don't know. It's not.
You got
it's not
trees and
crazy
stuff,
well
right?
protected. Some, but the house next door gets shaded a lot more than it does. But anyway, solar's part of it, but that's not all of it with that house. And that's wintertime temperatures that I'm thinking there anyway. So this house has been sealed and insulated, and it's got a variable speed, right size equipment. So it's running. So that's pulling the humidity down, which means the set points oftentimes go up pretty consistently from clients. This is what we see. And then that cool air is washing across the surfaces and helping reduce hot spots. So this has good mean radiant temperature. The average of the surface temperatures here is pretty decent. So you can do this in part with just one or the other. It works best with both, meaning shell and HVAC. And how we communicate this within the free quote process is showing different types of equipment. So this is a basic system versus a 2-stage hybrid, a variable hybrid, and a best variable speed hybrid. And a single stage piece of equipment doesn't load match for squat. It can't match what the house needs to what it's putting out more than a few hours a year, if that, because usually they're too large anyway, both heating and cooling. If you move to a 2-stage, it gets a little bit better. variable gets quite a bit better. That's usually a large jump. And then the true variable speed that dropped down to 25% of capacity, if you size that right, houses get awesome. But this is one way to communicate it to clients. Jeff, looks like you want to say something.
No, the only thing I would say is be very, very careful because, the typical salesperson you see in a home, if we're reaching out to clients and stuff or homeowners, is if they want to go up in size because it's multi-stage, question it, right? Why are you going up? Because there's nothing worse than buying a overpriced multi-stage, single stage piece of equipment, because that's exactly what they get.
Or variable speed.
Yeah, your lowest output is 2.5 tons, and your last system was 3 tons. So why'd you buy a 5-ton?
Yeah,
when 3 tons was
it's always going to run in 3-ton and low.
Yeah, doesn't make any sense. It's really
and Jason
sad.
hit it.
Actually, I've seen
long
that.
run times, right?
Yep.
So how do you have that conversation, Nate?
That's where some videos and talking about how car HVAC is really useful. In your car, can you adjust fan speed? Can you adjust how hot or cold the air is coming out? Yep. Can your house? Nope. Would you like it to be able to?
I have a new vehicle and the software is not there yet. So playing with the temperature on my drive today to Columbus was a nightmare. So, 69 heat would be on. All of a sudden AC's on, bump it to 74, AC's on, just cold air blowing on you. So then you're hitting 80. So, that's how I envision people that are uncomfortable in their home.
So if the sun's coming in the window just the wrong way, the sensor senses the sun, and so it thinks it needs to be air conditioning. And
yeah, I hate those. Our old house had valves for hydronics that weren't working well anymore, and the kitchen was either 60 or 85. There was no in the middle. You were either shivering or sweating, and it was obnoxious. So yeah, done wrong, that's the kind of thing you get. But it's tough convincing typical homeowners, but you need third-party education fundamentally is what you need, because coming from us as salespeople, not so much. But if I'm the third-party arbiter, it can oftentimes be okay. But yeah, that's a challenging thing to communicate, but that's part of what we're trying to do with this right here. All right, different ways of installing as well. So Jeff, I kind of want to bounce this one off of you. So if you're running a heat pump and you're getting complaints of cold air coming out, would you dial back the airflow a little bit to raise the temperature of the air coming out of the vents?
It varies. Yeah, I know some manufacturers, being out in the field with some engineers from like American Standard Train, they want it to run at 450 CFM per ton on all their variable speed equipment, right? So they want the heat pump to run at that. So
Jason Sear
yeah, exactly.
It depends where the vent is, doesn't it? If the homeowner's like, oh, that's a little too cold and it blows on me, then you change it. And if they don't have a place where they're in the house and that's a little too cold and it blows on them, then you don't change it.
Yep. In cold and blowing on them, is it just the blower that's running? Or is it actually, hey, the heat pump's running and it's just cooler than normal air? Obviously, at that point, we're going to dive in to see what's going on with the airflow setups and then the charge and make sure that the heat pump's set up correctly. And that's where we find 90+% of systems that have some sort of setup fault on new installs.
I hear Jim Bergman somehow somewhere saying something. Yeah. I mean, if the charge is wrong, that's one thing that I meant to throw in here and forgot to put in, which is like charge is more critical with heat pumps than it is with air conditioners. You can't get away with as much anymore. So that's going to be one challenge as we move towards that. But you can also hook up Measure Quick and at least get kind of close. If you're charging it when it's cold out, it's going to be a challenge because they're best charged when it's warm out. But you can get at least kind of close, and then at your first maintenance, you can double check.
Typical weigh in per length of line, and what the system comes charged at. But I mean, there was a year or two where I had a bunch of Carrier Infinity systems, that were charged for double what they should be from factory.
From
So
the
then you
fact.
were adding plus the line set lean, and we'd go back out, So
Well, that's another good place to test because I'm sure that popped up in the pressures, right?
yeah. I mean, or the installers would be out, and you're getting an alert that day if you've got it connected, or a call from the client,
Yeah,
letting you know what's going on. So
yeah. That should be enough to pop an error, right?
yeah, oh, absolutely. Yep.
Um,
It
so
would. You'll get high discharge temperature and stuff like that on the sensors, and it alerts you through the controller. So
it's all three of us have a bit of a love affair with carrier equipment, for better or for worse, or their control in particular. But yeah, it's each one of them. One week we should have Tim Portman come on because he is a giant trained American Standard guy. So we get into Ford versus Chevy arguments. So can yours do that? Well, no. But can yours do this? Well, no. It's always kind of funny. So thanks, Jay. So Jay said, that's why I like y'all. Y'all have built a process to at least attempt to communicate all of this to a homeowner in an hour or less. It's a tough battle you have here. Amen, brother. Because we got a lot of hair on fire homeowners and my furnace is out, my air conditioner's out. World's gonna end. Like that's really a challenging situation, and that's 80% plus of replacements. But for what it's worth, I got it down to 5.5 minutes of video, 4 minutes on the 6 functions, and 1.5 minutes on duct pressure. If they will slow down,
and that stuff's free too. You can save yourself $6 a month if you want to figure out the rest of the process yourself.
Right? Yeah. Oh man, getting that down to 4 minutes. That's one of the harder things I've done. That sucks. Let's see. So in the last challenge that I wanted to talk about tonight was where to set changeover temps, and I'm thinking in particular hybrids here. But Jeff, I'm curious what some of your feedback is on this. So a couple different things I had in mind. Should that temperature get set higher where it kicks over to the furnace at a higher temperature if you've got a high duct pressure system that you can't fix? Should we be setting this as low as possible for comfort, which is usually what I do? I had one client that I loved. He was an amazing client, but I asked him, so you want me to set this for comfort or set this for efficiency? And he said, well, efficiency and cost. Like, okay, so I said it exactly what I was going to do anyway. I totally gave him a false choice. Set it to 30 degrees, where the furnace couldn't work until it was below 30. That was a, 3-ton, 5-stage on top of a 60K mod in a 4,400 square foot ranch with a 4,400 square foot basement. Does just fine. And then should we consider doing things that are fuel cost dependent? Did I do? I don't think I did anything. Nope. So Jeff, what do you think on these three?
So as where to set that temperature, I'm a little different with that, where I will let it run heat pump only. So depending on the control that I put in, hey, we're going to put it to the heating sources, heat pump only. Let's kind of play that if we're not testing the home on a free quote, right?
Yeah.
Let it run. If you are able to get it connected to a Wi-Fi and control remotely, some of those settings I can adjust remotely. So, hey, you want me to kick your changeover temperature to 25 degrees because you noticed at 22 it lost a degree or two. Fantastic. Then we can do that.
Yep.
So that's where I usually will coach my homeowners and clients to, let's just let the heat pump do its thing. Keep an eye on it, notate it as it gets colder, let me know, and then we'll adjust. We'll change from there.
That's my strong preference too. I mean, the challenge here is going to be systems that have high duct pressure that we don't have an opportunity to adjust. That's going to be the hard one.
Well, so what's the airflow? 150 CFM per 10,000 BTU or something like that on the furnace? What's that rule? So if you had a 60,000 BTU,
yeah.
So if you had a 60,000 BTU furnace, basically 5 tons, on an air conditioner, you'd need 2,000 CFM 50, and on a furnace, you only need 900.
Something like that, yeah.
CFM.
Yeah, and that's part of why I'm suggesting if you're pushing your luck on duct pressure, maybe it's worth switching to the furnace sooner than you would otherwise. But
Saving
that's
the
going to hurt
equipment.
comfort. Yeah, you're trying to save the equipment there, but I mean that's a compromise working around something that's crappy. So ideally,
Well,
fix something else,
so
downsize,
is a
fix
hybrid.
the ductwork, whatever. Yeah, well, and a hybrid is its own compromise because you can't do reheat dehumidification with a hybrid; it's not possible. Um,
Well,
so
depending on your setup, your CFM for your heating to reach these efficiencies and stuff as well is actually higher than your cooling CFM. So whereas before we used to,
Per
like on
ton?
manual heat and stuff like that, we would talk about, yeah, I mean, we would talk about sizing it for the cooling load.
yeah,
Well, now we're seeing this shift for the high sensible heat ratios and everything else going on with the newer equipment to hit the higher efficiency ratings, the bigger coils, the warmer coils, less dehumidification, lower that blower speed, and you're seeing all of a sudden now that your heating CFM is higher than your cooling CFM. So
yep.
you have to take that into account when you're switching out a system to understand where that duct pressure is going to go as well.
Ding, ding, ding. See, Jeff, I knew you'd have some great feedback on that. So instead of an 80K furnace, you might want to run a 60 if you think you can get away with it. But be careful. Don't take responsibility that is going to bite you as well. My friend Stu Unsdorfer in Cleveland, for years, he would always take things down a size. So he did thousands of systems that way. And if memory serves, he had to replace 2 of them in upsize. So it wasn't a high percentage. It was a fraction of a percent that he actually got bit by downsizing. And he lost a fair number of jobs when everybody else was building an 8 or bidding an 80 and he was bidding a 60. And we worked on one of them, and that was kind of cool because it ended up, well, he almost had undersized it because the power went out for 8 hours and the house lost 20 degrees. And then it took 2 days to get it back. But once we fixed the shell, it flipped. Over 20 hours, it lost 8 degrees. So it took a long time for it to drop. And all of a sudden, that furnace was reasonably close. It was still too big. It was the house only needed a 3-ton heat pump to actually handle it. But it was cool to see.
Well, so and that
downsizing work.
Interesting to tell. The reason we knew that how slow it took to fall 20 degrees is the client went on vacation and set the thermostat back to 50, and he had an Ecobee. And we specifically did this as an experiment to see how long it would take to fall back. And what was it, like 15 degrees outside?
It wasn't quite that cold, but it was say 25, 30,
Okay.
which was the same conditions that he had before. It was a little below freezing.
Right.
And before that house fell off a cliff when he was losing 2 degrees an hour, and then he flipped to losing half a degree an hour. So that was pretty nice. And all of a sudden, he didn't have to worry about frozen pipes anymore. That freaked him out. That was a big reason that project sold. And that was a shell only project. The only thing we did on the HVAC was put that Ecobee in. Man, it was Ryan, that was fun to watch. Ryan Kerr, Armageddon happened. Should have had a 100K in it. I don't know.
That's one of those things we always talk about as well is, the temperature setback. You don't want to do it on a heat pump anyways, because you're going to increase the chance of your backup heat or resistance heat to kick on quicker, right? So that's the other thing is if you have somebody drop it back 10 degrees when they're gone during the day and they come home, that's a design day. What's going to happen? Yeah.
You're going to get a phone call. It's not keeping up.
Yep.
Yeah. Condensation starts to occur on the cold surfaces.
Yeah. There's all these pieces of the puzzle. Now, the fuel cost dependency, I do want to just at least touch on this because things have flipped. So electricity prices just went up, and they went up primarily because gas prices just went up. And because gas prices went up, coal prices went up too. So I live amongst coal miners. I have coal miner friends now. I wouldn't have expected that, but that's where I am. And a whole bunch of mines have just reopened because gas prices got so high that all of a sudden coal was economic again. So like green stuff didn't kill coal, natural gas and fracking killed coal. But now that we're connected to Europe, price-wise, and Asia, we're connected to the world. we can export a fair amount of gas, and that pulls our prices up. So that's what happened with the whole Russian mess last winter. And now we're just one crisis away from prices going up. So that first winter, gas prices doubled, but electric prices stayed the same. So that would be the winter to lean on your heat pump. And then now that electric prices have come up, at least for a while, and gas prices go back down, you might lean more on your furnace. So you have that option if you have the two fuels. If you don't have the two fuels, would you like gas, or propane, or oil, whatever you're running? So you can do this. Are you actually going to take the time, or is your client going to take the time to adjust this? Probably not.
Well, most people's heating costs are $500 to $1,000 a year, so you're not saving much on a monthly basis.
Nope.
You're not chasing a dinner out a month with your wife.
Yeah, exactly. I saw this years ago, Ted. I don't even know if I mentioned this. It was before I had really even begun to learn HVAC, but they had a hybrid, and they had it put in the late 90s. I think it might have been the previous owner, actually. And they had it set up to bury the needle with a heat pump. But gas prices were back down to being dirt cheap at that point, where they'd been 5 times that a couple of years earlier. Anyway, you have somewhere to go with hybrids on fuel costs. You have an option.
Yeah, if you're in Boston or California, your electric is going to be upside down unless you buy solar panels.
That's another thing. Yeah, it's too much focus on stupid stuff, and you end up with 50-cent electricity when most of the country's at 15. That's dumb. So that makes things hard. It doesn't make it easy. Actually, this is an interesting challenge. Do either one of you guys want to take this from Jay? Explain to me like I'm stupid or a 5-year-old why electrify everything is a good idea. Jeff, I'm curious to hear your thoughts in particular. I know where Ted is.
So I think there are so many reasons, but they have to be your reason. I got lots of reasons. I got these electric cars, and I can't ever imagine having anything else. They're just so much better. Like getting in a gasoline car just feels like a horse in a cart. And so, if that's not your reason, that's my reason, then that's not a meaningful reason for you.
Yeah.
I like the idea of moving away from fossil fuel dependence. In 2003, we decided to go to war with Iraq, which I thought was complete horse shit. It's when I decided that Hillary Clinton was the devil, because I'm like, I can't believe you're doing this. You're being so evil.
Good job, Ted.
Okay. And so this is when I started realizing that a lot of people that were just not a whole lot younger than me were going off to die for oil. And that to me is idiotic, because at the same time, we were talking about trying to scale up solar and renewables. And if we had leaned the other direction, we could have saved a whole lot of people.
Yeah.
Some 500,000 children died in Iraq.
So I think
that to me is idiocy.
I want
nothing to do with it.
So Jeff,
I agree. From my perspective, it's not what I want. Like Ted said as well, it's what the client wants, it's what the homeowner wants. It has to be their reason. However, if it can be justified with the fact of reheat dehumidification with like the Carrier, the Bryant, the Heil 5-stage, certain systems out there, the Trains, right?
The Train 1050s. Yep.
Yeah, that allows for lower costs on other things that they have to purchase. Like that, what we would install a whole house dehumidifier or a dedicated ducted dehumidification system to a home. Maybe their little portable standalones will take care of those off seasons. So it's more dependent on what someone may need. I agree with the electric vehicle. I can tell you right now, I've got one too. Right, just got it, had it a month, and I've spent a tenth of what I would spend in that month on actually charging that vehicle. So with what the
Well,
kilowatt,
and you do it in your garage. It's so
correct.
incredibly
Yeah.
convenient because and then you turn on your phone and preheat the car before you go out to it, and you don't have to worry about opening your garage door to
No gas in the
preheat
can.
your car.
Yeah.
So hybrids, I'm good with hybrids. Actually, it's what the majority of the systems that people put in my area. It's never had maybe a heat pump before. So I'm perfectly happy with that, perfectly okay with that. However, as these meter fees do go up, and I know Trammell earlier said, what about 2-3 years? They're already going up. Yeah, they're going to keep going up. Like I said, I was in Columbus today, and Columbia Gas in Columbus, Ohio, has already informed all of their homeowners that January 1st of 2025, it's going to go up to that $60+ a month.
As people abandon their meters, there's going to be a smaller population to share the infrastructure cost.
Yep.
And so that it doesn't have
worse.
a choice but to go up.
Yep.
Yep.
Yeah, that's called the utility death spiral. And that's just a matter of time as that comes. And Jay, one of the other things that's going on is we will have the challenges of transmission and distribution, to be sure. The wires getting stuff to your house, that's going to be a little bit interesting because some of that stuff's getting older. But solar and wind are now the least expensive sources of energy that mankind has known in history. That's just happened over the last couple of years. So economics ultimately drive everything. I say that math wins. It just takes longer than it should. I definitely thought about that with like The Big Short. When those guys are like, how come the mortgage industry hasn't imploded yet? What's going on? It's just like hanging out over a cliff and they're waiting for it to fall. That is how things tend to work politically. The math turns, and then it takes a little while for everything to actually go the direction that it should. But that's where we're going. But also, every vet that I've talked to, almost every's probably too strong, but everyone I can think of, when I ask, so why were you away? Like, we're protecting our access to oil. And so the energy independence is not free, or being able to have the energy that we need. So this gives us another way to have our own energy.
And somebody doing a conversion from gas to electric, in my opinion, would be stupid. I mean, it makes no sense. If you're not testing, if you're not understanding what's going on with that house, just throwing in a total electric system to electrify is just, I mean, idiocracy.
Risk fraught with a lot of risk. You're setting yourself up for frustration and disappointment. It's better to get figured out what the house needs before you stick it in than having to replace it.
Or do a hybrid.
But actually, if you want to do it whatever way you want to do it, our process sets it up so that the homeowner, they get to, Tim, whose chart we were looking at earlier, he had a homeowner come back to him after a year and replace a brand new system that he had sold them the year before with a better system. And they were, they're like, you were right. We should have used that better system. So let's do it.
It's wild. So, I know that's not going to fully satisfy you, Jay, because you've got a comment after this that I'll pop up in a second. But fundamentally, it's the way things are going to head because of economics, and also the experiences of cars and HVAC in particular are substantially better with electric options. That's new. That didn't used to be the case. But man, the inverter, that changed everything for heat pumps. Single and two-stage stuff, meh. Like it had mentioned basically your father's Oldsmobile earlier. Like, well, my mom had one, didn't like it. It was your mom's heat pump. It's not your father's Oldsmobile. If anybody remembers that campaign. It keeps life interesting, but it's where we're headed one way or another. It's just a matter of speed. And actually, I'll touch on that more in just a second here too. But I want to touch on Jay's thought here too. So then, after we remove meters from point of use, we burn natural gas to create electricity and transmission losses.
Sure.
Well, to an extent, but the other thing is, if If you want to spend
If
some
it's
time
cheap.
Googling, well, there will be times when it's cheap, but take a look at the transmission queues, the stuff that is wanting to be connected to the grid, and they are generally between 80 and 90% solar and wind and batteries right now. So that's what's coming because it's the least expensive stuff. Will we still need gas and oil in the peak days? Uh-huh. And um, we we do other things when things are dire, uh, but it's not necessarily that much usage at the end of the day. Um, but it's a good thought, and it, Ted. How long ago was it that we dug into clean energy space? I mean, the Energy Gang. I listened to that for a while and learned that, and been on there too. But yeah, it's kind of where we're going, and we can do a better job for our clients with electric options. So that's kind of how I view it.
So this is interesting because electric vehicles aren't being forced into the marketplace. The way electric vehicles are going to take over the marketplace is they're going to be the cheapest and best way to solve the transportation problem on an individual basis.
Yep.
So my car drives me to the gym every day. I don't drive it. It drives me. That's nice. I get to check my email. I get to it is so much better than any other car that exists on the planet. And people don't realize this until they get in one and live with it. Well, Ronnie bought one on Monday. So he's at the point where he's like, I can't believe this thing exists. He's at the very beginning of that. So the cars just need to be cheaper than the alternative. And then you look stupid for not doing it, which is okay because there are going to be stupid people out there, but they're going to be, most people are smart and they're going to be like, well, why would I spend more for shittier when I could spend less for better? And so the cars are going to be like, that's how the cars are going to transition. But you're right about the heat pumps. The heat pumps are going to be a much harder thing because they're always going to cost more than an air conditioner because there's more to them. But
Yep,
Nate will
at least
talk
more.
about one way to make them actually cost less, and you cost
Or the
less
same.
by making it up, or the same by making it up on lower inventory and manufacturing costs and all the complications associated with that.
Total Tech has a bunch of good comments in here. I mean, it's ultimately BTUs are BTUs. Yep,
That's right.
The house is warm. The house is warm. People don't necessarily care
And
how
you
it
want,
got
and
there.
the more control you have over the velocity of injecting those BTUs, the happier the client is.
Yep. Yeah. Put them
Or
in nice and
removing those
slow.
BTUs.
Slow and easy. Prohibiting the sale of
California
gas
doesn't
vehicles,
count.
enforcing the consumer.
Totally agree. Totally
Yeah.
asinine.
Yep.
But what are you going to do? There's a bunch of 9-year-old girls running the state of California.
It's going to be
what are you
interesting
gonna do
out there.
about it?
It's been running. Yeah. So you can move.
Just,
and Europe
just
is doing
ignore
that
it.
as well.
Don't live there.
Most of the country,
If you live
not
there,
going to do
move.
that. That's not a U.S. thing. And even the countries that are doing it, the U.K. just moved their target from 2030 to 2035.
A buddy of mine has a 1,100 horsepower Mustang, and then he's got one of the brand new Mustangs. I don't know, that's 700 or 800 horsepower. And then he's got a Resto Mod convertible Mustang, which is also like 800 horsepower. Those things, he's not going to ever get rid of those.
Why would he? Although, you know what? Peter and Dexlinger, one of my clients, has definitely become a good friend. He had a Roush Mustang, took me for a ride in it. The thing didn't hook up until it was doing 80 or 90 miles an hour. It just spun the tires all the way to that. But it actually was just dumb.
Brad's is a super snake.
Yeah. I just thought it was dumb. I want traction.
Vegas to have all that shit done to it.
our car guy sides are here. All right. Well,
Yeah.
we're diverging enough. But
Yeah.
Ted and I both have a healthy streak of car guy. I don't, Jeff. I
Yeah.
don't know
Yeah.
how wide of a streak you have. I know you have somewhat, but we haven't gotten into it. Did you have any cool cars when you were younger, or are you just like it's transportation for the most part?
Transportation.
Well,
I mean, a couple
you
BMWs,
bought this car.
Camaros, but and then
Beamers and Camaros. You got to care a little bit about cars.
Yep.
So there
Well,
you go.
he just went full early adopter, so that's somebody that cares about cars.
That's true. Yeah,
It
exactly.
has been waiting 3 years, so
Yeah, it took a
That's
while.
true.
Took a while. So
I've been waiting longer.
What, for the Cybertruck?
Yeah.
yeah. Well,
And
I've
both
been
of
in
us
that
need-
too. So
Oh God.
There's plenty of us. We'll see how many of those orders actually turn into orders when we get there. So another killer comment here from Total Tech. The mindset of consumer adoption is the best comparison, but the two markets very different. Yeah, so you're talking about early adopters, well, the innovators and early adopters. That's your first 16%, and you get your fat part of the bell curve, which is 68%, and then your laggards on the other side. Like my in-laws were hilarious. They only got a smartphone when they couldn't buy a flip phone. That's when they finally converted. So they had no choice. But yeah, what we're talking about here is mainstream market on the heat pump side. That's part of why we're suggesting hybrids as being the easiest and fastest path. So even though it's not my preferred path, given the choice, I'm getting rid of the gas meter. I just am. I like induction for the cooking.
We need to design.
The dryer, I don't care.
We need to design for the early majority.
Yeah, that's where we are.
So the user experience is early majority user experience, not early adopter user experience, because the early adopter user experience requires too many sacrifices. And frankly, I like driving these cars to Florida and Texas and Colorado and stuff. And I no longer am an early adopter. I have no patience for waiting for the car to charge. So when I'm done with my break, I just go to the car and get back in it and drive. And they charge fast enough that you can do this now. When I first started doing it, I was like, I had a Chevy Bolt, and the fast charging didn't come for over a year in my area. So I was charging for 4 and 5 hours if I wanted to drive more than 150 miles away.
You did some crazy stuff, man. That's that little smart that you had, where you're like,
gosh.
well, we're at this party for 4 hours because we won't make it home if we aren't.
Oh, that's right. We went down to Honey Eye Lake, and I'm like, okay, so we're gonna plug in here, and you better get along with everybody for at least 3 or 4 hours.
Man, those short range cars should come with a bottle of Valium. I mean, those things that you thought it was fun and it was adventure, and I just remember being anxious the whole time. Well, you knew that we were going to make it there. You had enough experience, but now you don't need any of that stuff. We're in the mainstream. I used to
throw my bikes on the back of that tiny little thing and go to Ontario County Park, and I had to ride my bike for 2 hours.
So it would charge to get home.
So it would have enough to get me home.
It was a fun little car, though, I have to say. That little rear-wheel drive thing, that was fun.
So anyway, sorry to go off, take us off, but
we'll
we agree with all of these things that you're saying. Yes.
Yeah.
There's a lot of penalty cannot exist in what we're doing here with heat pumps, or it fails. And Nate's already been to battle with, who are these assholes in California with the Electrify whatever group?
Yeah. So let's just not. I don't even want to name them. We're moving on.
Okay.
You can go back a few episodes and I definitely name them. You don't want leads.
Land this jet for Total Tech. He likes the jet back here. That's mocking those. Just so
he's messing around. He's messing around. Actually, there we are. You got to wait for the
crowd.
Yeah. Okay.
Yeah, 3 weeks. No, 2 weeks. 2 weeks. Actually, he's right. It is 3 weeks. Oh, yeah.
Or is it? It's November 30th.
It's 3 weeks for the Cybertruck.
It's 2 weeks and a day, or 2 weeks and 2 days. Anyway, whatever.
2 weeks.
Elon's 2 weeks is we got to celebrate it in a couple of days.
3 months.
Yeah, I think he's watched the Money Pit too many times. So when's this thing gonna be done? 2 weeks.
2 weeks.
Yeah, that's things do
FSD
happen.
is going to be done in 2 weeks. 2 weeks.
It's silly. It's silly.
These
Okay,
windshield
so-
wipers are going to work. 2 weeks.
Coming in for a landing here on our 2 weeks. So some heat pump challenges that you want to make sure that you work through. So these things, again, they consistently give consumer experiences that are amazing, particularly variable speed stuff. But you need to have a plan for how you're going to deal with high external static pressure or duct pressure. How are you going to size correctly? And oftentimes you're sizing to duct pressure. They're really good at providing comfort, but you want to pay attention. And then what are you going to do with your changeover temps if you're running a hybrid? So these are a few practical challenges to think through, but we don't view any of these that hard. And we built a process that basically helps you automatically avoid all these problems. So either you avoid them or you say, okay, Mr. and Mrs. Homeowner, this is a likely problem. I'm not taking this. Do you want me to test, or do you want to do something else, or do you just want to roll the dice? And then you get like what Tim did, and you end up installing another system a year later. So these are challenges that are all totally overcomable. But I want to end on something that it's been working for a while here, called the Cooler Act. There's actually one version that came out last year called the Heater Act, and it cracked me up that they called it the Cooler. And I actually love why, because heat pumps are cooler than air conditioners. So it just cracked me up. I thought that was great branding on the part of Senator
Cooler than the
Heinrich's
Heater Act.
office. Yeah, it's definitely that. The Heater Act was some sausage. This came out of a thread that I wrote 2.5 years ago on
It's pretty
Twitter.
clean.
It's really clean. It's got a couple of minor adders to keep people happy, but it's not that much. And I was hoping this would go to manufacturers because it's cheaper to do it to manufacturers than it is to distributors. But fundamentally, this offers not a giant sum, $250 for every unit, or $500 if you're just going to do the air conditioners that you're turning the heat pumps. But it pays it to the distributors to stock only heat pumps, and that way we get all hybrids at a minimum. And where the last one, it was definitely pretty messy, and like I would read some of it and be like, what does this say in English? This, you can read the bill and actually make it through it and understand what it's doing. So there's a few other little things that are on top of it, like if you move to all Energy Star, you get an extra $250 for per Energy Star unit. But it's really simple. And fundamentally, if we want to move to more heat pumps, which there's a bunch of reasons for, this is going to save a bunch of people money, particularly if you are in a rural market. Like I live in a rural market. There's no gas
They
anywhere
can't stock
near
stuff.
where I'm.
They can't stock
What's that?
stuff. They can't
Yeah,
stock
well, yeah,
all,
exactly.
all the SKUs.
No,
So like this'll
don't
be
find it.
just make it so much nicer at the supply house. And by the way, you don't even have to tell people that you're installing a heat pump. They just get it.
Yeah.
You don't even
there's
have to
only a
run
few
it as a
things-
heat pump. They just have it.
Yeah, I mean, if you really hate it, buy one that the reversing valve only engages for heating, or put a shoot. Well, I can't think of a solenoid in it. But that's not it. What's the word, Jeff? I'm looking for, where you basically hold the reversing valve closed all the time.
Just a relay, or I mean, it depends on what you're
Yeah,
trying to
Do a relay.
to it.
Yeah. I mean, if you want to be dumb and do that, okay. You don't have to use.
No,
the
there might
capacity.
be situations where it's the right call. Who
Yeah.
knows?
But this would mean if you replace an air conditioner, at least it's a heat pump. And Total Tech, I think, said earlier too, talking about when one of your heating system fails. This gives you 2 heating systems, not just one. So, even if the heat pump isn't enough to heat the house to 70 degrees on its own, you can bet that it'll heat it to 50 or 60. so that it's not a crisis, and then a couple of space heaters will get you the rest if the furnace goes.
Not only that,
Or
now
if
you
the
got
heat pump goes,
if
you
you
got
got the
furnace.
crappiest system, you got two stages of heat on the crappiest systems.
Yeah, exactly. But you still have all of your choices open to you. This is doubling your heating fuel choices, so that you don't get that. Now I see why he's really annoyed. This sucks. Had to buy an EV because the gas cars were sold out. That is how you make haters. Don't do that. Um, this is just taking something like, Ken Dean puts it aptly. He says that an air conditioner is a crippled heat pump, which is also fitting because Ken had polio when he was a kid. So one of his hands looks a little bit funky because of the polio. So he's like, yeah, I view that like this. Air conditioners are dumb. But if you force stuff and there are no other options, that's how you
I'm not
get
sure that if that actually happened, it's probably not the EV's fault.
Yeah. Well, actually,
Probably
gas
something.
stock has also been low right now. I mean, car inventory has been low in various places.
I mean, blame the pandemic.
All right, Ted. Now we're taking you off, Mike. So it's definitely the future. I'm pro heat pump for the record. So this is a simple way to get it done. Because there's only two main parts that you have to add: the defrost board and the reversing valve. Are there a few other parts? Yes. Are there a few other changes? Yes, of course. This is a pretty simple thing to switch over, and now we've got things that go two directions that used to just go one. So that's the idea behind this. So it's kind of cool to have an idea actually hit Congress not all that long after you put it out there. But big thanks to Clasp and Steve Pantano and Matt Malinowski, and of course Alexander Gard-Murray for turning it into a paper, and then it turned into a bill. So this is meant to be not sucky compared to a lot of other things. We're very much on the record for hating the structure of the IRA. It makes all of our lives in the field harder. Trying to sell stuff, it limits what we can sell. We have to bring up subjects before we want to bring them up. There's a lot of challenges with it. I would just as soon not have any of those things in there. Blame the unions for what car you can or can't buy. That definitely made things interesting. But this is coming. It's coming out of Senator Martin Heinrich's office. So we're actually presently looking for a Republican to sponsor it from the Senate as well. And it's funny because politically I lean right. We have definitely a bipartisan group that we're playing with in that. So anyway, that is what I wanted to touch on. And I will also put a link when this video posts, because I couldn't find it for the life of me. There's a sign up form. So if you like this idea, you can support it. And we're looking to get contractors from all 50 states to say, yeah, I like the idea of going from air conditioners to heat pumps and having it be cheap. This should cost the same, maybe as much as a third or a fifth of what the IRA is likely to cost, and it will have probably about 100x the effect. There's some model numbers coming out of the IRA and what it's going to do to heat pumps. It's going to add less than 600,000 units over a decade, and we're selling 6 million air conditioners per year. So that's about 1% is what it moves over. I'm not happy about it. None of us here are happy about it. This is another way to actually get that done and do it much more quickly and cheaply and constructively. Thoughts, Jeff? Ted?
No, it's great.
So there we are.
So an HVAC 2.0 free quote will allow the HVAC contractor to make sure he's positioned himself with the customer so that the customer is understanding their risk and explicitly assuming it. And it's documented.
Yep. Yeah, you got to do that. Offer the options and
let them pick.
Pluses and minuses are and go from there. Exactly. So what we're suggesting here doesn't remove choices. And that's the key part.
Yeah, it's the same thing with the EV. People don't. Where's that great slide where Bender takes the sign and turns it into a boat?
Yeah. The boat says no boating, and he folds the sign up into a boat and sails away. That's fighting the screw you. I won't do what you tell me. Natural human instinct that all of us have in one way or another. So yeah, it's you don't want to force this. Could you argue that this is forcing? Yeah, but this is adding choice. This is adding a heating fuel that wasn't there before. And most likely it's going to be adding comfort. Because Ted, how many times have we heard from our clients? Yeah, you don't have to use it for one. And in clients,
you don't have to tell them to even have it if you don't want to.
Yeah, you don't have to do that.
You're selling them an air conditioner.
But the clients tend to like the heat pump heat. Jeff, how many times have you heard that? Like I've had one exception, but Ted, that was Ed from EKA Build after you'd badgered him too much. He's like, I like the furnace. But everybody else has been like, yeah, I like it when the heat pump's running more. I mean, Jim Bergman blew my mind because when we first met, he was Mr. Gasify everything. And I started talking about mean radiant temperature, what we were showing here. And now he has a hybrid and his wife is like, I want that heat pump running, man. So it's funny. Like you just have to experience it
too. He's into it too.
Yeah. Well, I mean, he put the Cooler Act in the email blast this week. So yeah, Jim agrees that hybrids are the best first stop for broad market. We can do more later, but this is the easy first step.
All right.
We made it to silence. So
that's
I think we've all said what we want to say. Everyone, thank you for coming. Thanks for the comments.
Thank you.
Jay and Total Tech, thank you. Like, this is a sticky and complicated thing, and it's taken a while. But heck, I mean, Ted, this all went back to your mom's house, ironically, when you put that hybrid in. And
2010 was it?
Yeah, and they didn't turn the furnace on. They didn't turn the gas valve on, so the furnace couldn't run.
The installer locked out the gas valve.
Yeah.
And it was never turned on. Like 3 degrees outdoors. And it was 10 o'clock at night. And she calls me and says, God, the house has been wonderful. We really love all the work that we did and how comfortable it is. And there's never any dust now because the filter works so well. But I just walked past a register and the air felt a little bit cold. Says 70 degrees at the thermostat, but the air felt a little cold, and so I thought I'd call.
Yep, and you were like, son of a, they left the gas valve off. And also, why do we have a furnace at that point?
Why do we have a furnace in that house? It's not going to get colder than this.
So, I mean, it was a logical conclusion more than anything else. Well, we don't need that much output, so why should we have it?
Had a 60,000 BTU furnace and a 3-ton heat pump. And the 3-ton heat pump was heating the place. I'm like, wow, that furnace is oversized.
Well, that was an old 2-stage, right? That was before
Actually, it was a 3-stage. It ramped down to 20. So okay. it was good. It was a good fit, but
it's still just fine. Well, no, not the furnace. I mean, the heat pump was
that was a 2-stage. Yes.
Yeah, pre-inverter. So anyway, all this actually comes out of pragmatic experience at the end of the day.
And mistakes.
Yeah. Oh, and yeah. It's my favorite line. Ask me how I know that. And all three of us here have made a bunch of mistakes to come to our own conclusions. So anyway, thank you everyone for coming, and we will see you next week.
Good night.